Machine screws. I'm actually going backwards now, aren't I? Because I did structural, then I did machine, then I did PK, then I did PK, then machine. Now I'll do structural. All right, structural. Structural screws. All right, similar in strength to an AN bolt. Similar. Strength to an AN bolt. They have a grip length. And remember, other screws do not. They're just threaded all the way up. And have, I was right about that, have an X for steel. Or a dash for stainless. Stainless on the head. You know, this may seem like, oh gosh, but you know, as junior mechanics getting out in the field, it's this little stuff that's going to kind of set you apart when you can understand screws and bolts. You're not doing stupid things like grabbing a bolt with a drilled shank and looking for a self-locking nut to go over it. It's like, it just makes you look bad. Stacking 16 washers up because you didn't grab the right bolt. So how many washers did you use?
No more than 4 or an eighth of an inch.
Wow, this guy's got it. So, all right, let's see, nut plates. Nut plates. I'll pull a picture of nut plates. All right, so we did that. Are those structural?
Type A is not. No. Both of them are.
Nope, because sheet metal screws are not structural. Or PK. What are these? This is right there. Tinnerman nuts. These are cage type, so you can see they make a little U. So your aluminum is going to go right in between like that. These are the not cage types. You got to hold them while you go. And you hold them with your finger, and then you put the screw in, and then you screw the screw right into your finger, and then you back it out a turn so you can get your finger back out of the way. Phillips head truss screws. Are these structural?
Nope.
No.
How come?
There's no
They got threads all the way up.
Threads all the way up. All right. Countersunk. Structural?
Nope.
Nope.
Yeah.
Yes, structural. Because
That's a grip.
that's grip.
That looks more like a bolt.
All right. Structural?
Yeah.
Okay. Because it says it right there. Structural stainless steel. Unless you're watching it online and my picture's right over here and you can't see stainless. So, okay. Nut plates. Nut plates suck. And the reason why is because they wear out. And how do you suppose they're held in place? Rivets. So they're riveted in place. So they suck for a lot of reasons. Suck reason number one is they're self-locking. So this is crimped, that's crimped, and that has the nylon in it. These are a little bit easier to use, but if you're putting a screw in there that is non-structural, they're a little bit softer. And the softness of the screw head in your screwdriver is a little bit softer than the hardness of this. So it tends to want to strip out the head every single time. If you're using a screw gun, guaranteed you're going to be hating your life unless you get a lot of pressure in there. But they come in all different kinds. And then they crack right here and break off. And so then you have to drill the rivets and re-rivet it, and that's never fun. And the reason why you're in there, why it's there, is because it's really hard to get a nut on the backside because there's no room. So now you get to get a bucking bar in there where there was no room for a nut. It was great with, and usually I think they're installed on a piece of metal, then that piece of metal is then riveted into the aircraft. It's not the other way around. So you're after the fact.
Nifty little squeezer.
Yeah, I don't think you're going to get that in the plane.
But you can get a bucking bar in.
All right. Oh, the only thing that sucks worse than these is those. So we'll get back to that.
I thought there's blind rivets that you don't have to have a bucking bar.
Is it what? Oh, there are blind rivets. Yes. It's kind of considered bad form to use blind rivets. Number one, they're pretty pricey. They're about $1.20 a piece.
How do you
Especially-
use a blind rivet?
Huh?
How do you use a blind rivet?
Well, I'll get to that.
Okay.
Yeah.
So you're saying that some of those are screwed on the shield and aluminum before they're put on the plane?
Riveted.
Riveted on, so that means if you needed to replace some of those, you'd have to remove that aluminum sheet.
There's usually a way to get to it, but you hate it. It's
Okay.
like way back in and up, and you got a bucking bar up in there. You can barely do it, and sometimes you're using something for a bucking bar you shouldn't be, like just a nut, because the only thing you can get on your finger on, and it's like it's just the being an aircraft mechanic. So, and then you just don't look. You're like, yeah, it's holding. When the screw goes through, it'll hold it in place. The rivets are only there to hold this in place till you get the screw in. Trust me, it is. Actually, Cessna, they have airworthiness directives on these nut plates on the Cessna 150s. They used 8 of them to hold the horizontal stabilizer on, and they were cracking.
That's a no.
No.
So you just have to check them now?
Every annual, I think it is. It's at least every annual. The mirror, go up in there and look at them. All right, so structural screws, nut plates. So nut plates, maybe a machine thread. Most of the examples I showed you there were machine thread. They don't have to be. Could be, or for Tinnerman nuts. So Tinnerman nuts. All right, that's all I got to say about that. Then there's Dell clamps. Nobody enjoys Dell clamps.
Dell makes pretty good rivet.
And this is just making me, okay. There we go, move that there. Dell clamps. The thing about Dell clamps, you use a lot of Dell clamps. So where do you start with the Dell clamps? Well, you put something in the middle here, and then you spring this down right here, and guess what? That hole will line up half a hole with that. That hole does not line up with that. So you use an ice pick or an awl, then you put that in there, and then you use needle nose pliers, and you bring it down, and then you pull your awl out, and then it goes, eek, and that's off a hole. So then you realign it, and use vice grips, and you hold with vice grips, and then they make a tool now that actually kind of holds them if you can get it in there. But and then the next thing is, see how like this is for a number 10, that one's for a number 8, and so you realize that you need to do this one, but you need a number, or this one, and you got the wrong hole. A guy I worked with almost lost his finger. So he wanted to drill one of these out. It was like a number 10, and he needed to be a 1/4 inch. And so he went to the drill press, he put a 1/4 inch bit in, and he put the Dell clamp around his finger and held it that way. And you know what happens when a drill bit catches thin sheet metal like that? These are steel usually. They're not aluminum, they're steel. And some are aluminum, but like that one's steel, I think those are aluminum. But anyway, it grabbed and just ripped his finger. So, I don't know, Dell clamps, there you go. That's all I'm gonna say about that, or cushion clamps. They suck. What sucks even worse are Rivnuts. These all suck. You know what doesn't suck? A good old-fashioned bolt and a nut. They're fantastic. Give me a bolt and a nut. So these are Rivnuts, as the name implies, I think. Yeah, okay. It's part rivet, part nut. And like I was working on Remoses, and they use a whole bunch of them. You usually use them around non-structural stuff. So it's this nut rivet that goes in, and you squeeze it, and when you're done, you have threads. See how that would work? Okay, kind of like a little pop rivet, sort of. Let me see. Do I have a? There we go.
So you just screw it in and it'll crush it, kind of?
Kind of. Let's see. Don't blink. Boom. There it is.
Easy.
How do I do that again? Goes in, tool goes in, squeeze the tool, comes like that, remove the tool, now a nut goes in there. Stop.
That's so interesting.
All right. What happens though is if you're not careful and you cross thread it just a little bit or don't get it lined up perfect, that rib nut starts to spin. And once it starts to spin, it always spins. And so now but inevitably a mechanic will not stop at that point and either re-squeeze it or put a new one in. They get a drill gun and really go to town. Boy, you get that thing spinning, it really wears a nice hole in the sheet metal. Now you're never going to get it right, and you'll be, for the rest of the aircraft's life, you'll have loose Rivnuts in there. So maybe it's a decent thing. Maybe it's the mechanics are the problem. I don't know, but they don't hold up well. If I was building a plane and it called for Rivnuts, I would figure something else out. I don't like Rivnuts. They don't last long. So we had the Dell Clamps. We talked about Rivnuts.
If something did call for something like that, when can you choose what fasteners you're going to use?
Well, if it's a home built,
Oh.
you can do whatever you want.
Oh,
If it's a certified aircraft, you're going to use what they tell you to use. Rivnuts. And then Zeus, like my dog. Although I wrote it with an E here. I don't spell his name with an E. So Zeus. Yeah, I didn't think there was an E. And Camlock.
Is that how you spell your dog's name?
Yeah.
That's expect nothing else.
Yeah, everybody thinks it's Zeus like the god Zeus, but no, it's Zeus like the fastener. He doesn't know. I tried to explain it.
You're named after a fastener.
Yes. I should have named him Moose. All right, Zeus fasteners. These are cool. They're just quarter turn. Use them on cowlings and stuff like that. They're fine if they work. Camlock. My airplane has far too many of these. I think maybe 10. 10 is more than enough. I'd rather just have a good old-fashioned screw. Yeah.
You don't normally see these fasteners on like high speed or anything fast.
Cowlings, yeah.
Oh, okay.
Yeah. Well, fast to you is not the same as fast to me. So fast to me is like a fast piston engine. Fast to you is, you're, yeah. I don't think U2 is real fast, but.
Oh, 3 quarters of an
So, yeah, okay. But, yeah, I think, trying to remember the citations use these two, I think.
We use them on cowlings.
Yeah. So it's just real common for cowlings.
Yeah.
Cowlings on everything. Cessna loves them.
Actually, I think they also use them on the nose, but I can't remember.
But just a quarter turning in, and like these are kind of cool because this is all solid. Like my aircraft uses a rubber mount. This part here is rubber with a bonded piece of metal, so the rubber often wears out and breaks, and so.
Do those get corroded though?
No, not really. Well, that's all I was gonna say. I was just showing it to you. Just still. All right. So you asked about Cherry Max. Let me see. Let's see. Blind rivets. So there's all, and you're gonna get. I think with Larry, he'll go over all this, but I'll just kind of let me see. Cherry Max. Cherry Max are kind of the industry leaders. Let me see. There's a. I thought I had little videos. Yeah. Let's try this. No, same thing. Tutorials. All right, so what about them? Blind rivets used under certain conditions where there is access to only one side of the structure. Typically, the locking characteristics of a blind rivet are not as good as a driven rivet. Therefore, blind rivets are usually not used when driven rivets can be installed. Blind rivets shall not be used, 1, in fluid-tight areas, 2, on aircraft, air intake areas where the rivet may be ingested by the engine, the aircraft, control surfaces, hinges, hinge bracket, flight control actuating systems. A lot of places you're not supposed to use them. And this is out of 4313. Caution, for metal repairs to the airframe, the use of blind rivets must be specifically authorized by the airframe manufacturer or approved by a representative of the FAA. That was one of the changes in 4313 1B. The one prior to that, you could use blind rivets. They were kind of silent on that. I think actually the statement was something to the, I know it was something effective, blind rivets shall not be used unless it's in an area where the loss of one or two will not appreciably affect the characteristics of the repair or something of that nature. So you could use them. Now, 4313, so you can't use 4313 to use blind rivets at all. So they're saying, nope, you can't. You have to have specific authorization by the airframe manufacturer, which means you'd go to like the Cessna structural manual or Piper or whatever, look at the repair, and it would say something like you can use blind rivets. I just throw that out there. You'll get blind rivets with Larry. High locks, funny, I don't use high locks. I see them. I never had to put one in. It's basically a threaded fastener which combines the best features of a rivet and a bolt. Kind of like a Rivnut, but better. Consists of two parts, a threaded pin and a high lock collar. Is rapidly and quietly installed. Quietly. That's just, they're not aircraft mechanics. Standard power tools. So there's Vidya. All right, where are we here? We had Zeus and Camlock. We had blind rivets. Which I said Larry will cover. Let me see. And then I just showed you high locks and stuff. So that brings me to bolt torque. All right, so before I get on to bolt torque, do a quick little review. Everybody up to speed here. Bolts. Okay, remember, I don't need you to necessarily know all the part numbers, but you do need to know how to understand at least the AN bolt since it's so ubiquitous or everywhere. So the length, remember, is not counting the head. So if this was an AN 5-9, what is that?
The shank is
5/16
diameter.
Diameter by
1 1/8 inch length.
I caught her.
Say again?
It's 5-9.
5-9.
Yeah.
There's no 9.
There is no 9.
It goes straight from 7 to 10.
7 to 10. Okay. Sorry. So if it's a 5-12, what is it?
5/16 and 1 2/8.
5-12. So 5-12. So it's how wide?
5/16.
5/16 by
1 1/4.
1 inch and 2/8, which is 1 1/4. Everybody follow? If I said it's an AN5 Hotel 12, what does it have? Has a hole in the head. Is this one an A or not an A? Not an A. What if it's got an A?
There is no
Shank hole.
Absent the hole. No hole. And if it's a CH, stainless with a
Hole in the head.
hole in the head. Okay. That's what we just said. All right. This part right here is called, well, it says right there. Never mind. That's the grip. That's the nominal length. Again, understand that if I measured this and I said it's an inch from right there to right there, that's exactly 1 inch from there to there. Then, and that's a 4, so it's a 1/4 inch. What would that be?
10.
AN.
4-10.
Well, why 10? Because it's a little bit longer.
Because they go higher, never shorter.
Right, so you might have an extra right there. You might have an extra 1/16 of an inch. You go back. Don't go forward. So they make them a little bit longer than they should be because they're cheap and they mass produce them. They're not going to make them exactly on the 8th. But they're never going to shortchange you. That's the nice bit. They always give you a little extra. So that's, if it's 1 inch exactly to right there and you have a little bit of change, it's 1 inch. A lot of you guys are getting your AN hardware 2 wrong because you're like, well, it's a little bit more than an inch, so
I want to round up.
you round up. Don't round up. You'll get it wrong.
Rivets.
You get it wrong. Okay.
Round up with a rivet.
The wrench size is not the...
Bolt size.
All right, Let's see. I should get rid of all the words and you could tell me. How do I know it's close tolerance?
Triangle.
Triangle.
Triangle. What is all this right here?
Manufacturer.
Okay, doesn't matter.
Drilled head. bolt,
Drilled head. These come in both
Fine and coarse.
fine and coarse. If it's coarse thread, what is it? Remember the part number?
Oh,
They're the 74s.
Uh,
74. What kind of nut is usually used on these?
it goes into a blind hole.
Goes into a blind hole. You don't usually see these with nuts. Why would you put all these safety wire holes if you had a nut on the end? That wouldn't make sense. Do
tendency.
you guys see Harry's cool bolt?
Yeah.
He's got his big old high strength shear bolt. What's special about these down here?
Very little thread.
Not much in the way of threads. Because why?
Just shear.
Shears, so what? You still got to put a nut.
But it's a small net.
Small nut, you can use your shear nut on it. Let's see, clevis bolts were used for what?
Shear.
Shear only, and what?
As like a hinge kind of. For
Subject, usually subject to rotation. That's why they're almost always drilled and need a
Counter pin.
cotter pin and castle nut. Eye bolt. Let's see, head markings. Nylon up to what temperature without looking? You're all covered up so you can't see.
There we go.
Can't see it now.
Up to 250. High temp is up to what temp then?
450.
450, all right.
Super high temps. Or
When can you reuse a self-locking nut?
if it's on 4313.
It meets the minimum prevailing torque of 4313. Minimum prevailing torque for 4313.
And that's for both the nylon and the.
It just says minimum prevailing torque values for reused self-locking nuts. So self-locking. Is this self-locking?
Yep.
Yep. Okay. Exhaust nuts. All right. Cotter pin. We talked about that. Thin pile nuts. Washers. Which lock washer can you reuse?
Split.
What about these?
Nope.
Nope.
Never.
All right. We had our screw head types. Which one of these are structural?
Handhead.
The washer head, pan head. Also this Philister, because it got an X. I shouldn't mess with you, but yeah, remember it said or an X, so probably that one. How about that one now? Nope. That one?
Yeah.
Can't really see, but
Yeah.
we'll say yes.
You can't see
Yeah. All right. Watch off. Tinnermans. What size do screws come in?
Number 4, 6, 8, 10.
4, 6, 8, 10. What size is the 10?
316.
All right.
You can go up to 12. Shit's getting crazy.
12 in Tinnerman nuts only.
Oh.
All right, Rivnuts. Discard. Let me do this. There, recording now. Yes. So in theory, now if you're watching it, notice how it even pulls the
Sheet metal.
sheet metal. Thank you. That's the word I wanted right there. Sheet metal together. And it does too. It really pulls hard. So use the pneumatic gun. It's just too much if you're trying. You can do them with a hand one, but you're there for a little while. Let me see. What else do we have? It's all pretty much the same. I don't know what these are. A Maxi Bolt. Come on.
I think you had to push like heat.
Just too fast. Is that it? Yeah.
Bottom one, Maxi Bolt.
Huh?
There we go. Oh, you were on.
Unisync.
All the way to the bottom.
Third one down.
Maxi Bolt. Thank you. Not where I was looking.
Whoa. Oh.
Yeah, so they make some pretty exotic stuff here.
Wow. Those look expensive too.
Yeah. Okay. Let's see. All right, that brings me to bolt torque. There, I'm glad we did that. All right, bolt torque. First rule of bolt torque is bolt size. All right, so bolt torque is something that is very underrated. Right? There's a lot of things that we're going to start covering from here to the rest of this class, starting with bolt torque, where it's one of those things where everybody's like, come on, I mean, how hard could it possibly be? Yet they screw it up in the worst way. Then we're going to move on to non-destructive testing, where it's the same thing. It's like, well, it looks so easy. It must be. Everybody can do it. Everybody does do it, and they screw it up, and people get hurt. So, for example, I used to have my little 150 across the field, and somebody else over there, saw me working on my plane. He came up, hey, you know anything about engines? I don't know, a little bit. And wow, what's going on? And he said, well, I keep having, I'll fly my airplane and then I'll look inside the cowling and then there'll be a stud missing, holding my cylinders on. And it keeps happening, like over and over. So then I got to take it in the shop, and I got to go in, they got to get the stud out, put a new stud in, and put it on. It's really getting annoying. Why is it doing that? Well, why is it doing that? Because the person who put it together didn't properly torque those nuts holding the cylinders on. And what that particular thing is, when you're torquing something, there's so much going on, and I'll try to explain it all to the best of my ability, but there's way more going on than what you normally see or even think about. So for example, like on a cylinder, you have a piston moving up, you have the compression, you have the, you okay back there? You getting comfortable? You've got then the fuel is ignited, you've got the pressure, it's pushing the piston. Well, it's pushing the piston this way, but at the same time, it's trying to make the cylinder go that way, okay? And so when it has bolts and studs that hold on the cylinder. Well, the idea is, it's engineered so that the tension of the bolts has to be more than what the cylinder is ever going to do. So if the bolts were tightened, but they weren't tightened as much as the cylinder is trying to be forced away, every time it fires, the cylinder tries to move away just a little bit, and it does. It stretches the bolt just a little bit, every time, until it work hardens and boop, then they start falling off. So in order to torque this properly, or the idea is you actually torque these bolts so that they are tighter and under more tension than the cylinder will ever experience. So they are tight and they're locked in and under all this tension, and really what's happening in the cylinder is inconsequential to them. They're like, go ahead, because man, we are so tight over here, you're just kind of doing your little thing. We are, they're very tight. So you have to tighten it to that. Well, why would somebody not torque it enough? I mean, how hard could it be? You look in a book and it says go to 600 inch-pounds. So you get a torque wrench, you go, click, 600 inch-pounds. I did it, right?
No.
Why not?
It's dry.
Number one, it's dry. And instructions may say something very clearly about you shall use a wet torque that is is a 100 weight oil mixed with 15% STP, or you guys have had that class, or maybe it's a food grade lubricant. I mean, it's very, very specific. So, yeah.
Do you do like stretching the bolt as well, going to like a certain?
Yeah, that's a whole other thing. But just talking about the simple act of using a torque wrench. So, if you don't use lubricant, then you're going to lose maybe 40% of the torque that you should have had. So, consider this: when an engineer sits down and they think this bolt has to be pulled to this tightness, they don't think about you twisting the nut. What they're really thinking about is, how do we get this bolt to stretch that much? And what is at your disposal? Well, the only thing you have at your disposal is how much you twist the nut. So how much you twist the nut will equate to how much it is pulled. So in a perfect world, we would never ever use a torque wrench. Well, that's not my perfect world, but in an engineer's perfect world, they would throw away, I'm speaking for them, they would throw away all the torque wrenches, and we would always measure how far every bolt has been stretched. You'd use a big micrometer. So let's take, for example, Lycoming. They do it with their high-end engines, their more higher compression engines. Their connecting rod bolts, that's how you do it. Now, it's a little bit more complicated. You actually have to torque them to a certain amount, then you measure it, then you retorque it, and you're checking to see that they didn't overstretch based upon a certain amount of torque. There's checks in. But the ultimate thing is you actually measure it with the micrometer to see how much you tightened them. That's how you do it. That's the right way. Okay, so when you're twisting a nut, it's not about twisting, it's about the pull. But we don't have a way to measure that, so we do it based upon twists. So in other words, an engineer figures out if, like on this Lycoming, if you twist it correctly, this nut, to an equivalent of 300 inch-pounds or 600 inch-pounds, twisting, that will equal a stretch of this if you did it correctly and used the right lubricant. Fail in any one of the doing it correctly, the technique, the reading it, or the wrong lubricant, then you've under-torqued it, and then you have an engine that comes apart, which is very bad. So, yeah, so something very simple is actually very complicated. So we have to do it right. And at the same way, there's technique involved. There's a lot of different types of torque wrenches. There's click type, dial type, beam type. I'll show you all these things. But, you know, one of the favorites is, for the longest time, is click type. And I like click type because they're really easy. You can look at it, you can set it, it's there. And, you know, you're doing 600 inch-pounds. You guys have done 600 inch-pounds. If you have a short, you're kind of shaking, and it's a lot. It's 600 pounds at 1 inch, or what is that at a foot? I don't know. 12 by 12, I know, I can't do that fast. So, yeah, I was going to say it's more than 30, so 50 pounds at a foot. So, you know, some of you little pipsqueak guys, you're really, you know, you're in there and you're trying to read it at the same time. All right, so that's why I like click type. You can set it and hold it just right, get a nice click. But if you jerk it, you can click it really fast. And then you can get maybe, you know, only 1% of the torque because you were fast. You got to bring it on. And also their starting and stopping is bad in some cases because there's torque to get it going again. So if you're supposed to go to 600 but you stopped at 550, then you're going to start again. It may not want to start again. It'll click before it starts again because there's a certain amount of torque to get it going, and then once it gets going, then you go. So it's all about technique, how you hold it. Yep, hold it too far in. Hold the head while you're doing it. So some of you guys, you know, I saw you doing some weird stuff putting your engines together. I'm like, no, let's go over to the little torque meter and let's do the same procedure. And like, oh man, I am really putting some torque on. Or you're clicking way before you should have. So, so we want to actually pay attention when we do this. So it really does matter. Some torques, like on engines, they're critical, especially like I was talking about holding cylinders on. If you get it wrong, cylinder's going to come off. And if you haven't been around planes much, when a cylinder comes off, that's actually a bad thing. Sometimes it's just a little bolt and you're no big deal and you're just using a torque wrench simply so you don't strip it out. It's not critical. It's not under, you know, maybe under shear load anyway. It's like, it doesn't matter, but you want to make sure it's tight enough. So how much time we got? You guys look like you're ready to go. So I guess it's time to go. So with that in mind.